Hello everybody. In this video, we are going to be dealing with reduction formula. So this is the next cameo that we have with the cast diagram. In one of the other videos where we used the cast diagram, so using Cartesian planes with trigonometry, we dealt with cast diagrams, and we know that cast, which is C-A-S-T, is where the fourth quadrant is C, where all cosines are positive. The first quadrant where all the trig functions are positive. Quadrant 2 is where sine is positive and tan is positive in quadrant 3. So it spells out the word cast in that order. Okay. Now we are going to be learning reduction formula. Now with reduction, usually it comes in the form of when we have maybe a trig function. So let's say, for example, sine, and we have some angle. The reduction angle could either be, so maybe I should rather quickly do it like this. It can either be sine, cos, or tan, okay? And then it will be of either, it can be 180 degrees, or it could be 360 degrees, plus or minus some theta. So this is usually when we use, this is an example of reduction angles, right? If we think about it, because these are the reducing angles that we will remove, but then we're going to need to manipulate the trig ratio accordingly, and we will go over that. I'm just trying to let you understand that these are the reducing angles, these are the trig functions that we're dealing with. Either one of them are going to be used and nothing more within our curriculum, and it will be either plus or it will be minus theta or x. Well, in this case, let's use theta because we're used to theta being the angle. So yeah, from here, let's start with the A, right? All meaning everything is positive, right? So we don't really need to focus too much on the reduction change here. The reduction happens usually within quadrant 2, 3, and 4. Why? Because we can see that the change over here is 180 degrees is here, 90 degrees is here, 0 degrees is here, 270 degrees is here, and this can also be 360 degrees. So notice that we're mainly focusing on 180 degrees and 360 degrees. And that is where we introduce the 180 plus or minus theta. Okay, so we're going to start with quadrant 2. And we're going to go through all of them. Okay, so this is 180 degrees minus theta. So we can place a theta somewhere here, and that will just be 180 degrees minus theta. Okay, because you're going from 180 degrees backwards with some acute angle theta. Okay, so let's draw our trig ratios over here. So with our trig ratios, the ones that we usually look at is in this order. So sine 180 degrees minus theta. Okay, just note that this quadrant is 180 degrees minus theta. This quadrant here is 180 degrees plus theta, because it's after now, after 180 degrees. And then this quadrant 4 is going to be 360 degrees minus theta. Okay. And obviously quadrant 1 would usually be represented as 360 degrees plus theta. Okay. Okay. Now let's go back to the sine over here. Okay. So we have sine of 180 degrees minus theta. And what is this going to be, right? This is where we reduce the reducing angle and get rid of it. But we need to make a change to the sign. Notice that we are in quadrant 2 where sine is positive, meaning our output is going to be positive sine of theta, where we got rid of the reducing angle and left theta on its own. That is the whole point of using reduction formula. With cosine, notice that cos 180 degrees minus theta. Notice that cos is not positive in this quadrant. So therefore, the answer would be minus cos theta, and then we get rid of this reducing angle. And then same thing with tan, right? 180 degrees minus theta. Notice that tan is in quadrant 2, and tan would be negative. So it would be negative tan theta. Okay. Now that we've dealt with that part, let's go to quadrant 3. And then let's deal with sine 180 degrees. Because this is quadrant 3, it's 180 degrees plus theta. Meaning that our answer, which I keep writing so far over there, will it be negative or positive? Well, notice that we're in tangents quadrant, meaning tan is the only one that can be positive. So this one will be negative sine theta. Okay, we reduce the angle and we keep theta. Then we work with cos 180 degrees minus plus theta. Okay, that looks very ugly. This is just going to be negative cos theta. Why? Because it is in tans quadrant. So that means that tangent 180 plus theta must be equal to positive tan theta. Why? Because it's its own quadrant. And then the same thing applies for quadrant number 4. So we will have something that looks like this, okay? So pay attention to the quadrant and where they lie in, and the only additions that I've really made was that there's all positive in the quadrant 1, meaning there's no negative sign. So if it was, let's say, for example, 90 minus theta, the sign will stay positive. But that is when we learn co-ratios, which we will get into right now. And then, obviously, there's this part here, which I added. So, yeah, you can go to that. Let's go into co-ratios. So, for our co-ratios, or if you want to say co-functions, it's the same thing, but we're working with trig ratios, right? Or functions, if you will. Okay. So let's deal with the first quadrant, right? So the first quadrant, I'll just say here Q1. Okay. So with quadrant 1, I'm going to deal with sine and cos. So we'll have sine of, the co-ratios work when we have a reducing angle of 90 degrees. So this is the only extra reduction angle that we're really going to add, but this is a special type of reduction angle where it's 90 degrees, and it usually only works with 90 degrees. So if we have 90 degrees minus theta, like I said, we keep it in the first quadrant, here, notice that 90 degrees minus theta, everything is positive, meaning the answer will be positive. So you always look at the reduction angle first, and then once you see, because we have the 90 degrees, we have to change the sign to cos. Meaning it will be positive cos, and then we reduce the angle to theta. And then if we're dealing with cos of 90 degrees minus theta, then we look at which quadrant it is. It's in quadrant 1. Everything is positive, so therefore the answer will be positive. Then the cos changed to sine because it's 90 degrees, so it'll be sine theta where it's reduced to. Now we're going to be dealing with those in quadrant 2, right? Because, I mean, we dealt with 90 degrees minus theta, but what about 90 degrees plus theta, which is in quadrant 2? So what about sine of 90 degrees plus theta? What is that going to be? Now we're going to look at the quadrant first. Notice that it's in quadrant 2, okay? I mean, it is there, but I mean, like, by analysis. 90 degrees plus theta is in quadrant 2, which means that it is where sine is positive. And notice that it is already sine. So meaning we deal with the plus sign first, and then we deal with the changing. Remember, it's not going to be negative just because it's going to change the cos, but we usually think about the original first before we change it. Okay. Now we can change it to cos because of the 90 degrees, and we reduce it to theta. Okay. Then the last one here that we have is cos of 90 degrees plus theta. And what is this going to be? I want you to try and see what it's going to be now. So you can obviously just take your time over there. You can pause the video. So right now we have 90 degrees plus theta, where sine is only positive, right? Everything else is negative. And the trig ratio or trig function that we have here is cos, meaning that it's in the wrong quadrant to be positive. So it will be negative. And because it's 90 degrees, we need to change it to sine, okay? And then we reduce it to theta. So one thing to take away over here is that the sine and cos we will be working with that have co-ratios, okay? So this is sticking to our curriculum. So this is the parts that you need to know in terms of co-ratios. So now we are on negative angles. So this is actually one of the last parts that I'm going to really be doing, which is very detailed. Then I'm going to be doing an example which combines all of them. And then I'm going to do one more thing. I'm going to tell you right now what it's going to be. It's going to be where you're given some value, right? Like you're just given one angle, but then you need to rewrite it in a way where you can reduce it, and then you can maybe like use no calculator, and then you have to use a special triangle to actually evaluate. So it's a question such as that. So you might know what I'm talking about, you might not know what I'm talking about, but there is quite a lot in this video that I want to put in, like just so that everyone knows what to expect, okay, with these stuff. So don't rush the video, take your time, just do some practice questions outside of this, and then obviously do it one by one. It should be good. Anyway, with that aside, we're dealing with negative angles, right? So this applies with just about anything when you can get like either just negative theta, or you have like a trig function with negative as a common factor. It always works with both of them, right? I'll tell you what I'm talking about when we do the examples, okay? But for now, let's stick with negative theta, right? So the angle that we're dealing with is negative theta. So meaning we're going to have sine of negative theta, we are going to have cos of negative theta, and we are going to have tan of negative theta. Okay. So from this one over here, what do you notice? Negative theta is in quadrant 4, right? Because we always assume that theta is some acute angle. Okay? So because it is, we notice it's going to be lying in the 4th quadrant. And in the 4th quadrant, we know that cosine is positive. Meaning, every single ratio that is not cosine is going to be positive, is going to be negative. So notice that cosine would be positive theta, and then we get rid of the negative sign. So usually, this is where we reduce the negative sign, okay? So you can even look at it as like maybe sine of 0 degrees minus theta, right? Because it is 0, it is starting from 0, and then we're subtracting the theta as well. Okay, and also it is subtracting from 360, so yeah, we have that part. So negative angles, and then the sign would be negative because it's in quadrant 4, right? Sine's only positive in quadrant 1 and 2, and then tan is only positive in quadrant 3 and quadrant 1. Okay, and that is for negative angles. And then you'll also see like there's another funny little application when it comes to negative angles and in terms of manipulation I'm talking about. So let me keep this one in like a green just so you can kind of see that you could also look at it in this way. Okay, now let's get to the examples just so we see what's up with these questions. So here's our first question. Example 1 says simplify cos square 360 degrees minus theta plus cos square of 90 degrees plus theta. So this looks a little bit like interesting because we have a square, right? There is a square here, it looks very funny. But what if I told you that with these trig ratios or trig functions that we have here, we can just do this, right? We can just take the whole thing, and we know that this square is actually affecting the entirety of the trig function. We just take the square outside, so we'll just be left with cos of 360 degrees minus theta all squared. So this is what it actually looks like with the square, okay? And we do the exact same thing with the other one. So we take cos of 90 degrees plus theta, and then we square it, okay? Now we can deal with the inside alone, so we don't have to stress too much. So 360 degrees minus theta, what quadrant is that? That quadrant is quadrant 4, right? And isn't quadrant 4 where cos is positive? So therefore, we'll just have cos, and then we can reduce the angle and say this is theta. And don't forget about the square, by the way. And then the other one, since we remember the square is there, we have cos of 90 degrees plus theta. Okay, and 90 degrees plus theta we know is quadrant 2, where quadrant 2 cos is negative. So it's going to be negative cos, or sorry, negative sine, because remember it's also a co-ratio since it's 90 degrees. So it's negative sine theta. We reduce the angle as well. Okay, and this is being squared. And then from here, notice that we can just say this is the same as cos squared theta plus negative sine squared, or negative sine theta all squared is just positive sine squared theta. Okay, and then notice that this is just an identity. We know that cos squared theta plus sine squared theta is just our identity that says sine squared theta plus cos squared theta is equal to 1. So therefore, the answer to this one is just 1. Okay, now I know what you're thinking. This is quite a lot. This is a big jump from the last question. So there is a lot happening, but to be honest with you, this is super easy. So let's go through it together. This is equal to sine of theta minus 180 degrees, right? So we need to work with each of these individually, okay? So let's work with the first bracket, okay? Sine of theta minus 180 degrees. The reducing angle is not in the place it should be. So we need to change that. We need to make sure that it's in the first position, okay? So the best thing that we can do is we can take out negative as a common factor, because we also don't want a negative to be in front of the reducing angle. So we can take out negative as a common factor, and then we have 180 degrees minus theta, because remember that the theta was positive. So now we change it to minus because it got a negative as a common factor. Cool. Now we dealt with that part now, okay? We can come back to it later. Let's just do it one by one, okay? Multiplied by sine of 360 degrees minus theta. We know that 360 degrees minus theta is quadrant 4, okay? That's quadrant 4. And quadrant 4, we know cosine is positive, meaning that sine would be negative. So we would have negative sine of theta, where we reduce the angle to theta because the reducing angle is where it's supposed to be, and things are more simple from there. Now we have cos. Cos of 180 degrees minus theta. 180 minus theta is in quadrant 2, meaning sine is positive. So in this case, this will just be negative cos, right? And then we'll be reducing it to theta. And then the other one is going to be 360 minus theta with cos, okay? So we know cos is positive with 360 minus theta because that's quadrant 4. So therefore, it will just be positive cos theta, okay? And then the last one, in the denominator, we have sine of 90 degrees minus theta. Now notice 90 degrees minus theta is in quadrant 1, meaning everything is positive. So we'll keep the answer positive, and because it's 90 degrees, it's a co-ratio, meaning it'll change to cos, and then we just drop the 90 degrees. Okay, and it's positive because it's first quadrant. Cool. We got all of them out of the way except this one over here. Notice that this is sine of a negative angle. And what did we say about negative angles for sine? Well, the only trig ratio that's not affected by negative angles is actually cos. If we remember the theory behind that, cos is the only positive one when something is being negated. And it doesn't affect cos. But sine and tan, however, are affected, meaning this is just going to be a negative. So negative sine of 180 degrees minus theta. Notice how we just got rid of this negative. So now we can make things much easier to read, okay? But just because we're going to be wasting space over here, let's write that down in another color on top, okay? So this one will be written as negative sine of 180 degrees minus theta, okay? And we know that 180 degrees, we're going to do it right now, 180 degrees minus theta is in quadrant 2, right? And quadrant 2 sine is positive, so meaning it's going to stay as negative sine, because negative times positive is negative. Okay. So it will be negative sine of theta multiplied by negative sine theta minus negative cos theta, and then we'll multiply it by positive cos theta, okay? And this is all divided by cos theta. And then if we were to simplify it further, notice that the negatives, they will cancel out, because it's negative times a negative gives you a positive, and then these negatives will also cancel out, and then it'll give you a positive, right? So then we will be left with sine square theta plus cos square theta divided by cos theta. And remember that this is just nothing but the identity, which is equal to 1. So therefore we'll have 1 divided by cos theta. And if you want to be fancy, this is the same as sec theta. But we don't deal with those ratios from grade 11 and 12. Okay. Otherwise, this would be the answer to the question that we've just done. Now let's do one more type of questions that we can get for reduction, and then we do one example, and then we can call it a day for this lesson. Okay, so I know I said I would have done like some little thingy before the example, but honestly, this needs an example in order to teach, by the way. I'm just saying, because it's not that crazy. It's just we don't have theta this time, but we do have to deal with numbers, okay? I know it's your favorite part. However, probably not going to be your favorite part, even though there's numbers involved. Anyway, so we need to simplify sine of 330 degrees multiplied by cosine of 120 degrees plus tangent of 225 degrees. So what are we going to do from here? Now notice that 330 degrees is in which quadrant? This is in quadrant 4, right? 330 degrees, that's between 270 and 360 degrees. What about 120 degrees? Which quadrant is that? That's quadrant 2, because that's between 90 and 180. And 225 is between 180 and 270, meaning quadrant 3. Okay? So then we need to look at the behavior, okay? We need to know that this quadrant 4 is most likely just going to give an output of a negative value. The quadrant 2 for cos is also going to give a negative output. And quadrant 3 for tan is going to give it positive, because clearly tan is positive in quadrant 3. However, there's only one little addition that we need to think about for this one, okay? We need to break this up into a way where we can get a reduction angle as well as plussing or minusing some other angle to give us the 330 degrees, okay? So we need to break this 330 degrees up such that we have some reduction angle as well as another angle, just adding or subtracting with it. So for sine, what is the best reduction angle or closest reduction angle to 330 degrees? Well, we know it's 360 degrees. So what do we need to do with 360 degrees to get 330 degrees? Well, we need to minus 30 degrees, right? So there we go. This is our reduction angle. This is our theta, okay? Think about it that way. This would be represented as our theta. Okay. Now that we got that out of the way, we can multiply by cos, and then this 120. What angle is very close to, say, 120 that we can get? Well, there's actually two of them, right? There is two of them. There's 90 degrees, and there's also 180 degrees. You can choose either one of them you want. It won't make a difference. However, because I don't want to deal with changing anything or whatever, I want to now deal with 180 degrees, okay? So 180 degrees we have over here. What do we have to do with 180 to get 120? Well, we need to just subtract 60 degrees. And then now with tangent, with 225 we know that's close to 180 degrees, right? What do we need to do with 180 degrees to get 225? Well, we need to add 45 degrees. Okay, now that we did that, we have our standard question that we've just been answering. 360 degrees minus 30 degrees, that is quadrant 4. Now sine is going to be negative in quadrant 4, so it's going to be sine, and then we reduce that reducing angle, and then we're left with 30 degrees, okay? Next one is multiplied by cos. Well, we do not have to do all of that again. We need to multiply. We know that this is quadrant 2 and cos is negative in quadrant 2, meaning it's going to be multiplied by negative of cos, okay, of 60 degrees. We're just reducing the angle now. Plus, we have tan of 180 plus 45. We know that's quadrant 3, right? With quadrant 3, tan is positive, so it's just tan of 45 degrees because we reduced 180 degrees. Then we can simplify it. The negatives will cancel. Then we are just left with sine of 30 degrees. What is sine of 30 degrees? This is where we use our special triangles. Okay, so here's our special triangles, right? We need to find sine of 30 degrees, right? My alarm decided to go off at the worst time. Okay, sine of 30 degrees, right? Where's 30 degrees? 30 degrees is right here, right? So we need to find out, remember sine is opposite over hypotenuse. So it's going to be opposite divided by hypotenuse. Hypotenuse? We have 1 over 2, okay? So meaning we're going to have 1 over 2 multiplied by cos of 60 degrees. We know that 60 degrees is right here, and cos is adjacent over hypotenuse, which is also 1 over 2. Okay, and then we have plus tan of 45 degrees. We know 45 degrees is either here or the top over there for this triangle, and we know that tangent is going to be opposite over adjacent, which is 1 over 1. Okay, and then if we simplify this, we're going to get a half times a half, which is a quarter, plus 1 over 1, which is 1. And we know that 1 over 4 plus that will give us 5 over 4. Okay. So this is how we answer questions where they just give us a number. And from here, you should be fine to answer other questions. Good luck.